Welcome to Coach Agner's Math. Today we are going to be talking about more special angle pairs. So let's go ahead and get started without further ado. We're looking at example 1. I know that we are trying to find the value of x. There's a couple ways I can talk about this. I know that QR is a line, and anytime I have a line, that means I have 180 degrees. So I know I have 180 degrees on this side of my line. My angle QON is going to be 90 degrees. I know that by the box that has been made for me. And since that is 90 degrees and I have a total of 180 degrees, I would say 180 minus 90 for my line. I'm left with 90 degrees. So I know by that my angle NOR is also 90 degrees. So I would say that 90 degrees equals 3x minus 6. And solving for x from here is pretty simple, just a little algebra to go. We're going to add 6 to both sides and say 96 equals 3x, or I can say 32 equals x. Simple as that. Those angle pairs could be considered a linear pair, as they're both 90, or because they are both 90, I could also call them perpendicular lines. Looking down at example 2, I know that line LM and line UV intersect at point B. Find the value of x and the measure of angle LBV. So I want to find this measure angle at the end. So looking at my angle pairs, this is not perpendicular. It might be, but they did not tell me, so I cannot assume it. And it is not a linear pair, as I don't have two angles side by side or adjacent. So the other option that we have is we have what we call vertical angles. I know that vertical angles are always congruent. Okay, and it's important that you write that down. Vertical angles are congruent. So anytime things are congruent, that means that they are the same size, same shape, and I can set them equal to each other. So 3x minus 5 would equal 2x plus 1. So again, back to algebra. Minus 2x on both sides, plus 5 to both sides. Notice I'm taking 2 steps and turning them into 1. I'm going to say that 6 equals x. That's the first part of my answer. Now the second part of my answer, I must know the angle LBV. So take that 6 and plug it back in, and I would say that 3 times 6 minus 5 would be 18 minus 5, or 13 degrees. So I would say the measure of angle LBV equals 13 degrees. Now, because these are vertical angles, since this equals 13 degrees, I could also say that this equals 13 degrees. By definition, that's what allowed us to say that they are equal to each other. You plug in 6, you should find that when you plug in 6 on this side, you get 13 as well. Looking down at example 3. Line LN and line OP intersect at point M. Find the value of x and the measure of angle LMO and angle OMN. So this time they want us to find x, and then they want me to find LMO, and they want me to find OMN. Now notice, back to problem 1, I have these things on a line, and because it is on a line, that means I'm going to be dealing with 180 degrees. This takes it back to the angle addition postulate. If I have two things, two pieces, two parts, I can add them together to get the whole. So I'm going to say part 3x plus 4 plus part 5x minus 20 equals the whole, 180 degrees. Again, work a little magic with our algebra, combining like terms, and say 8x minus 16 equals 180, or 8x equals 196, dividing by 8. Go ahead and do some long division over here. That's going to be 2, 16, 36, which means I've got 4, which is 32.5. So I'll have 4 left. Going to drop my decimal down, and that will finish me out. So I will say that x equals 24.5. Now, that's not the end of my answer. I've got to plug it back in. I'm going to say the measure of angle LMO equals, and I'm going to say the measure of angle OMN equals. I need to find all 3 of these pieces in order to have my full answer. So, to make it easy on ourselves, we know that x is 24.5. So I'm going to say, I'm going to work with OMN first and say 3 times 24.5 plus 4, which is 60, 72, 73.5 plus 4, or 77.5 degrees for OMN. Now the best part about them being a linear pair is instead of having to plug it in and do more math, I can say OMN is my 77.5 degrees. So 180 minus my 77.5 degrees should give me my other angle, which is 102.5 degrees. So I can say that the measure of angle LMO is 102.5 degrees. And just like that, I found both angles off of my linear pair. Flipping over to the back side, looking at example number 4. If angle 1 and angle 2 are supplements, again remember the word supplement. It's important that you remember that that means they add up to 180 degrees. So 1 and 2 are supplements, with the measure of angle 1 being 3x plus 20 and the measure of angle 2 being 5x plus 8. Find the value of 8. Find the value of x. Again, this is just like the problem we just got done doing. Supplements are linear pairs as well, or can be linear pairs. So I can say 3x plus 20, that's my first part, plus 5x plus 8, which is my second part, equals the whole, and because it's supplements, I can say the whole is 180 degrees. So, combining like terms, say 8x plus 28 equals 180, or 8x equals 208. Do a little long division. Say 8, 208. So 2 puts me at 16, which gives me 48 left. So x would be 26. Now, on this one, it just asked for the value of x, so we did finish our problem. X is 26. And again, if they tell you they're supplements, you could draw yourself a picture and make them a linear pair. Although they may not always be, it is a great way to visualize what you're doing. Let's look at example 5. I know that CD is perpendicular. That's what that word means to us. That means perpendicular, which is another way to say 90 degrees. It is perpendicular to AB. The measure of angle 1 is 3x minus 2, and the measure of angle 2 is 4x plus 1. So we want to find the value of x. Again, we know that these are perpendicular, which makes them 90-degree angles. So I have 2 parts, and I know that my whole is 90, so I'm going to say part 1, 4x plus 1 plus part 2, 3x minus 2 equals 90 degrees. So 7x minus 1 equals 90 degrees, or 7x equals 89 degrees, which ends up working out. X would be 13. So x is 13. Let's go back and read our question. Is that what they asked us for? Find the value of x. Yes, it is. We are finished with our problem right there. Example number 6. Find the measure of an angle if the angle is 27 less than twice the supplement. Again, the word supplement tells us that we're going to say 180 minus x. And we know that the supplement is going to be 27 less, or we're looking for a number that's 27 less than twice the supplement. 2x minus 27. A little bit of algebra will get us to x. So I'm going to say plus x on both sides. I'm going to add 27 to both sides. X will cancel, 27 will cancel, and I'll say 207 equals 3x. Do a little long division for you. 207, 6 is 18, 27. Okay, so I know that x is equal to 69. Okay, it's easy as that. They asked us to find the measure of the angle, 27 less than twice the supplement. So we say x is 69. And we're going to say 27 less than twice that would be me saying 120, 138 minus 27, which is the same thing as me saying 111. 69 and 111 add up to 180 degrees, which again is the definition of supplemental angles. Two angles that add up to 180 degrees. Final step, example number 7. Find the measure of the angle if the supplement is 12 more than 3 times the complement. The complement, 90 minus x, equals 3 more, 3 times 12 more. Again, solving for x, we're going to say that 4x equals 78. Do a little bit of math there. We're going to find that 78 is going to be 1, 8, 0, let me do bad math here. That'd be a 9. Should make that a 2, and it'd be 19.5. Again, thank you for watching Coach Adkin Math, and hope you have a great day.